Carlos has taken an initial dose of a prescription medication. The relationship between the elapsed time t in hours, right? So it tells you how many, the unit is, since he took the first dose, and the amount of medication, m of t, so the amount of medication is m of t, in milligrams, in his bloodstream is modeled by the following function. Okay, so it tells you t is hours and m of t is the amount of medication in his bloodstream. Okay, so they tell you the function. M of t is equal to 20 times e to the negative 0.8 t. How many hours will Carlos have 1 milligram of medication remaining? In how many hours will Carlos have 1 milligram of medication remaining in his bloodstream? So what do they tell you? What do they give you? They don't give you time because it says in how many hours. So what are we looking for? If it says in how many hours, what are we looking for? We're looking for t. This is the unknown, right? So we don't know what t is, but we do know how many milligrams, right? M of t in milligrams is in his bloodstream, which is 1. So we know m of t is equal to 1. So we need to find at what time is m of t equal to 1. So m of what equals 1. But in order to do that, we need to solve for an exponent. Now, what do we use to solve for exponents? Logarithms, yeah. Okay, so we are going to have to do that, and we got to solve. So it's going to be m of t, which is 1. We just found out that is 1. So it's, I'm going to write this, we're going to write this off to the side over here. So we have 1 equals 20 1 equals 20 times e to the negative 0.8 t. We can't put this in logarithmic form until we get rid of that coefficient. So we're going to divide by 20 first. Right? So now we have 1 over 20. I moved it. All right, so we have 1 over 20, which is what? We can put it in, because there's already decimals in here, we can put it in decimal form. So 1 divided by 20 is 0.05. So we have 0.05 is equal to e to the negative 0.8 t. Now we have an exponential, basic exponential function, right? Y equals b to the x, whatever it is. And we can change this to logarithmic form. Now this is going to be log base e of what? 0.05 is equal to negative 0.8 t. All I did was change it to exponential form. That is it. Now, what is log base e the same thing as? It is the same thing as the natural log of 0.05 equals negative 0.8 t. Now, the good thing is that we don't even need to use a change of base formula because natural log is already in my calculator. So I'm literally going to take my handy dandy calculator and I'm going to put natural log of 0.05 and I get negative 2.9957. So I'm going to use, oh God, I'm going to do 996 because I would put negative 3, but that's not true. So 996 equals negative 0.8 t. How do we solve for t now? This is a basic algebra 1 equation now. Now we just divide by negative 0.8, negative 0.8, and we get t equals that concoction divided by negative, where's negative? Negative, there it is, negative 0.8 equals 3.745. So, what's the answer? It says round your answer if necessary to the nearest hundredth, which is, so it's going to be 3.75 hours. Done. We found what t was. So key things here. First thing we did was isolate your exponential, right? We got rid of that. Then key thing is we changed it to logarithmic form. And then we actually put it in natural logarithmic form. And then you just solved. So here was calculator work. Calculator calc. Okay, let's try one more. So we have the bacteria in a Petri dish culture are self-duplicating at a rapid pace. I don't know why. In my head, I saw Petri dish culture and I thought of food immediately. I was like, oh, yum. And then I was like, wait a second. Duplicating bacteria. Nope. Okay. So the bacteria in a Petri dish culture are self-duplicating at a rapid pace. The relationship between the elapsed time t in minutes and the number of bacteria b of t in the Petri dish is modeled by the following function. So how many bacteria will make up the culture after 120 minutes? This is easier than the first one because we're not solving for t. So we don't even need to use logarithms. Why do we not need to use logarithms? Because we are not solving for an exponent. We are solving for this. It says how many bacteria. This is your unknown here. This is given. So literally, watch this. B of 120 equals 10 times 2 to the 120 over 12, which means it's 10 times 2. 120 over 12 is what? 10. So you literally have to do 2 to the 10th power times 10 equals 10,240. So that took literally 30 seconds. Versus this one is going to take a little bit longer because you're solving for the exponent. So you are going to use logarithms. I hope you hear me while you're sleeping, like haunting you in your sleep, like my singing. Because honestly, like my singing is not that great. So you're like, oh my God, Miss Masood singing is in my head. And then you'll remember that when you're solving for the exponent, you're using a logarithm. I almost forgot my own song. Isn't that crazy? Anyways, all right, that's the lesson for today. You'll be practicing this next class.